also can be used to forecast. Again, but I explain later on, it's not something frequently used to produce forecasts using the result decomposition, because the result the result of the forecast is not as good as other method. Okay, but it is possible to produce forecast based on the result decomposition. Okay. So after we decompose our data into different subcomponent, trend, seasonal variation, seasonal index, we can use the information to produce forecast or to predict what's the possible or the potential possible values of the series for the future. Okay, for the next points of the data. Individual components are projected into the future and recombined to form a forecast of the underlying series. It rarely works well since it is difficult to obtain adequate forecast of the component, especially for the trend, okay, for the trend component. The trend cycle component is sometimes modeled as some parametric trend model, such as a linear or quadratic model. However, for many time series, the trend cycle component do not follow any parametric trend model. So I think the next lecture we discuss how to model trend using regression. So the trend using time trend in the regression model. So seasonal component for future years after we decompose. So you go back to this one. So after we decompose, what we can do, we use this as estimate for the future seasonal variation, seasonal index. So let's say you want to predict what is the possible value for the next few observation. For example, we want to make prediction for this part. Our data, we only have data up to this one, but we want to forecast or predict for the value of the series at this. So what we can do after we decompose, then we project this further, the trend is a smooth line representing the trend for the long term direction. So we project it further, and then we also, if it additive, this one negative, so if additive we plus with this one. If negative, you times. It depends on the type of decomposition you use, whether you use additive decomposition or negative decomposition. So seasonal component for future years can be based on seasonal component from the last full period of data. So we can just use this to estimate or to predict the seasonal variation of the index in the future for the future one. So it says, however, as the pattern is changing over time, this will not be adequate. But that's actually for active, also for manipulative is okay. So the regular component may be forecast as so we have so we have three components now. The trend we can use the trend part is one. We can use any parametric model. For example, you regress this, but do not use this part. You need to use the what we call as seasonal adjusted values. You remove the seasonal component and then use the adjusted value. You regress the adjusted value against time trend, and then you use that estimate or that model to predict the future value of the trend. Okay. For the case of seasonal, seasonal we just use this one. The one estimated here, we just use the exact value. For the random, how about this one? How to predict the future random? So that is given this one. So what we did, we just replace 0. We just assume the 0 because the average of the error for the additive is supposed to be 0 again. And then for one for additive decomposition, one for additive. So now we know how to use this information to make projection. So we use any model to project this further, the trend, and then we use the estimated trend Okay, plus if additive is manipulative. This example manipulative, but if additive plus this estimated value and then plus 0 for the future error plus 0. Okay, for manipulative, we project this using any model, any suitable model, project this further, and then times the estimated seasonal index for that particular month. Like you have monthly data, and then you just take that particular month, and then times 1 for the error, or error or random. Okay. So it is as listed here. First, perform classical decomposition, and then we compute seasonal adjusted series or deseasonalized series. So deseasonalized series YT, and then estimate regression model for instance a linear regression model. So although I mentioned that linear maybe is not the best, okay, maybe but in the next lecture we discuss how we can also consider quadratic model, for example, instead of linear. But this one linear means a straight line. Okay, I hope you still remember before linear. So we still represent a time trend variable. So perform decomposition and then get the seasonal adjusted value. From the result decomposition, you calculate the deseasonalized value of YT, seasonal adjusted value. Why we use this value? Why we use seasonal adjusted value of YT? So this seasonal value of YT. So we remember. So linear model. Remember, it is considered as a straight line, but it's not necessarily that you should use linear model. This is an example. An example, if we just use linear model to model the trend. So remember, I hope you have learned before. So intercept, then you have. Okay, so this is you use T time. So T means the space of value from 1, 2, 3 up to the last one. N or whatever symbol you use, let's say N. And then you have, so this is your. So you have the intercept, and then you have your regress again, time trend. So time trend is just a square value of the first one you put 1, second one you put 2, you have monthly data. You create a variable which is a sequence of number 1, 2, 3, 4 up to the last one. And so we have the error term. So why we use seasonal adjusted value for YT, not the T itself? Why we do not use T? Because remember here, basically here we want to model the trend, but remember in any model it must have the error term. That's why we use seasonal adjusted value, because remember seasonal adjusted value it is equal to T plus ET, so it has error term. So we need to have error. We should not use the tricks, the trend itself. We need to use seasonal adjusted value as our dependent variable, because in the model we have the error part, the error component. So you regress, and then you can estimate. So estimate number 4, the fitted equation, because fitted equation, and then you compute forecast of the seasonal adjusted value using this by replacing the value of T for our sample, and then after that you compute the forecast of YT itself. Depends on the type of decomposition. If it is additive, then you plus, and then if manipulative, you times. So this gives us forecast of the trend. See, this provides the forecast of the trend. Okay, to get the forecast of Y, you have to combine with the seasonal index. Okay. So the error term is just 0 lah for the case of negative. For the case of positive, basically we, as I explained earlier, it times 1, but because 1, it doesn't make any difference. So you open the example given here. So this one, soft drink data. So this also explained online textbook, but this approach in producing forecast is not frequently used because it is not really produce good forecast. But we can use it if you want to make forecast using it, then you can. So we perform. So this quarterly data. Okay, notice that quarterly data. So in order to estimate the trend, so you calculate the moving average for MA, and then calculate the center moving average. So this one you put number 2. Remember this one you take the first 4, this is number 2.5. So the first one you can either put number 2 or number 3, but this one you have to put number 3 lah. Second one. Understand that one? And then you calculate the trend values. So this is, okay, as I explained in the lecture now, because it looks like a little manipulative, so we use manipulative to calculate the trend. Then we divide, and we calculate this index just like before. Then you click component. So in this case, we do not normalize. So normalize is not something, it's not something compulsory, but you want to get the same value as what it used or are produced, then you have to normalize that. But for this example, we do not normalize this index. We can just use it. But remember, ideally, the average of seasonal index for mathematics is supposed to be equal to 1. But in this case, we just simply use the result without normalizing this index. For this example, you can do that. You also can normalize and then you calculate seasonal index value using normalize also can. Okay, so both are. That's acceptable. You ask people which one better, I think maybe better you normalize first. Okay. But for this example, we do not normalize it. We just use the estimated seasonal index to calculate seasonalized value. The seasonalized value of y. So we just remove the seasonal y over, so to get the one. And then the next step is to model. To estimate a model, let's say we assume or we decide to use just linear line or straight line or linear model to model the trend. So then we just use this one. Okay, so we regress this against time trend. So we have to create time trend variable. There's a sequence of value 1, 2, 3 up to the last one. And then you estimate the model to get the estimate of the intercept and the slope, beta 1, beta 0 hat and beta 1 hat. So if you use Excel, so this one you also can do that in views, because in views also produce synergistic value. That also can be done in views. But this one just show, for example, you just use Excel. So in Excel, if you want to estimate the model, then you just go to. So now you want to regress this as your dependent variable against the time trend variable. This. So if you use Excel, then you need to use data analysis tools equal to data and this one. Do you know how to estimate regression using in Excel? You know, right? It's quite simple. And I show you how. So, data analysis, you click this one, and then you choose regression. So in the next lecture we discuss about how to model the trend. So they just an example. it's not necessarily that you should use linear, you also can use quadratic. You look at the data, the estimate of trend looks like a curve. Maybe the use of quadratic is better. Okay. But again, as I explained in the notes, most of the time, the data, the method is not exactly follow the parametric method. Okay. Okay. So if we want to use this to estimate model, so your input Y range, your seasonal adjusted values, your input X range, independent variable is your time. So just use in sample data. In sample, so input Y range, you click this and select seasonal adjusted value in sample only up to this one. Okay, and then you click this, and then select your independent variable, which is time trend. So until number 44. 1, 2. Okay, and then just okay, just okay. So give you the estimate. So you have estimated or fitted equation. One, 3, 8, 0. Get the forecast of, see there's the value for time for t, equal to 45, 46, 47, 48. Okay, for our sample, we replace the value. So compute the forecast using that equation. Okay. So 1380 plus 75 times the t. Basically, this one you just need to calculate the outsample one, but you also can do the calculation from the example from the beginning. But what important is if you do this and you drag it down, and then this is actually the part that we want to get. We want to calculate the outsample, the forecast. The forecast of seasonal adjusted for our sample, the future one, the future points of the data. And then the last step. So this is give us projection of the trend for our sample. And then in order to get the projection of Y, you have to combine the projection of trend and the projection of seasonal index. It's because this is multiplicative, so you have to multiply this value, and then you get the forecast of the YT. So if you, in terms of the graph now, okay, so you have, so this is the forecast of, so this is the forecast of the trend. This is the forecast of the YT itself. that's how, what we can do by using the information produced through decomposition in order to make projection of the time series data. So this one just explanation lah. Okay, so one more thing to do is the relaxation one. So we do that, and you can, if you finish it, then you can go over it. Okay, so we only have 3 questions. So the first one, this is what we discussed in the previous lecture, how to calculate forecast accuracy given, okay, assume or considering an example given here where we have 3 set of values. First one, the actual data, and then we produce forecast using 2 different methods. For example, teach an example lah. Method 1, method 2, the forecast. So now calculate using what we discussed in the previous lecture to calculate the mean error, mean absolute error, mean square error, mean percentage error, and mean absolute percentage error in MEPE. And then repeat this one using the actual and forecast, the first forecast, and then repeat using the second forecast. So I have provided an Excel file that with the complete calculation. So if you the question number 1, so we have actual forecast using 2 different methods, and then if we calculate the first one. Error, just the difference between actual and forecast. Okay, actual minus forecast. I think I uploaded this second one. In the first one, you have to change C2. Why I put this one? So the first one minus this. Okay, so this minus forecast, actual minus forecast, that gives us error, and then you take average of error, so you get 6.225. And then absolute error, how to calculate absolute error? You just use absolute. If it has absolute of the error, so you get all the negative become positive, and then you calculate average, so you get MAE, mean absolute error. And then mean square error, so each of error you square, and then you take average, you get mean square error. And then percent error, how to calculate percent error? The error is y minus forecast, you get the error, so error over the actual value times 100, you get percent error. So again, you do the calculation for all, and then you take average. It is 2.55, that mean percent error. Remember, I mentioned before, mean error has a problem with positive cancel out negative. Similarly with MPE, positive value cancel out negative value. So we need to consider an alternative. Okay, so which is mean absolute percent error. So each of the error percent error you convert using absolute value. So all become positive and take average. And you get. Okay. So this is for the first one. You do the same for the second one. Okay. Okay, so D2 so you get the same. So now you make comparison. So in terms of the solution, if you compare method 1, forecast method 2, so based on ME, MEE, and MSE, method 2 is better. Why? Because it is for ME it is closer to 0. For MAE also the same. You also can say it's because it is smallest. Okay, because it produces smaller value of ME and MSE. But for ME you have to be careful. You cannot say you should select the smallest one, because just like the example I gave before now. So let's say you have negative 2, you have 2 positive 2 and negative 4. Then positive 2 is better, but negative 4 is smaller, right? So don't confuse them. Because the ME can be negative, can be positive, but MAE and MSE must be positive. It cannot be less than 0. So this one same. You see, you select the smaller one, but for ME you cannot. You don't say that we should select the smaller one, because we need it to be closest to 0, as close as possible to 0, because we want the error to be small. But if in terms of MPE, method 1 is better, because MPE is closer to 0. This one also smaller, and MPE is smaller. MPE also you cannot say, because it also can be positive. You cannot say must select smallest or smaller, because we need to be close to 0. Okay. So it depends lah. So in this case, you need to decide which you want to select based on which one, or you select based on overall assessment. So let's say 5, 3 out of 5, model 2 has 3 better measures. So but sometimes we know, I think we then prefer to use the MEPE, for example, as well as MAE and MSE as compared to this one, because it must be quite a problem. Negative, positive cancel out negative. Okay, now let us reproduce this result in R. If you have large numbers of, even if you produce forecast, I hope you have tried to do that. The given example in the previous lecture. There are 2 ways to calculate forecast accuracy in R. Whether you have the list of number like this, or you just get the forecast from the model itself. You estimate model, and then you get that from. So I think that one I hope you have tried, or if you haven't tried, please do that. The previous example that I shared before on how to calculate forecast accuracy in R. Now we do this for example, but this one we have to import data and then we calculate in R. I think in the views I haven't explained so far. As far as I know, we cannot. But if you use R, then you can just use accuracy function. Okay, now, in order to use accuracy function, okay, that's given here. I already provide you this one, the command. In order to use this accuracy function, we need to install forecast package first. If you haven't, please check. You type library forecast whether it has or not. If it doesn't have, then you have to install it first. Okay, so I need to install because the technician just reinstalled the R a few days ago, so I have to install the forecast package. You have no need to install, you just need to install it once, the first time. Okay, just like I mentioned before, you want when you install a package, just like you buy a book, you get a book and then you keep that book in your library. Every time you want to use whatever you have in that book, the function, then you just call it from your library, type library, and import the package. So this is one because the technician just reinstalled, so I need to install back the forecast package. So you go to tools. If you don't have this one, then you have to install it. So install packages, and I have to type forecast. And then install. So if you do not install, you cannot use because there are, when you install R, it has a basic function available, but certain functions not available. You have to get from package, contributor packages. So that function, accuracy function, provided in a package contributed by someone. I think you can search. We're going to use quite frequently the forecast package because it has a lot of useful function for time series analysis, including the ATS, AS smoothing. What else? ARIMA later on. ARIMA model. Okay, so we have already installed it, but before you use it, you have to type library forecast in order to call that book, okay, a package from the library. Okay, library again. Forecast. And okay, so now we need to import data. The data is given in Q1. Okay, Q1. So you go to File, Import Dataset, Excel, locate the file. Browse. Import, so we have the data import. So we have data actual, forecast method 1, forecast method 2. So now we want to calculate the accuracy. Okay. So again, I think you refer to the previous note and you want to know how to use it, you just type. You want to use you want to know how to use the function. You type the question mark and then type the name of the function. Just like you want to know how to use accuracy, and then you just type accuracy, and then it provides the explanation of how to use it. Okay. Okay, now we have downloaded the data, but before you use this data, you need to, in order to use data inside that data frame, you have to type attach. Otherwise, you cannot get the data. For example, you type actual actual, it says there is no object named actual, so you have to attach that one first. You type attach Q1. So now we have the data object, actual data, this one, and then we have forecast 1, forecast 2. So now we want to calculate the accuracy, forecast accuracy using accuracy function. So you type accuracy followed by forecast values first, so which is forecast 1, and then the second one is the actual data, actual. Enter, so you get the same what we calculated before in Excel for the first method. So you can do the same. You just change forecast 2. Okay. So again, later on, if you haven't tried the previous one, the one we compare, we get the forecast value directly from the model we estimate. That also can be done. That one it will provide more statistics, including tells you and so on. Question number 2. Consider the quarterly accuracy production data for 4 years. It's quarterly data. Estimate trend using certain moving average, using classical additive decomposition, calculate the component and normalize the index and recalculate regular component. I already provide the answers here. But now, reproduce this in views. So this is additive decomposition. So you have views Q1 here. Q2. So this one I hope you understand the step just like before, because this is quarterly data. So in terms of the place where we put the numbers is different, like to the monthly. So this is quarterly. So basically the same. So you open reviews Q2. So how to get the seasonal index as well as an adjusted values. So you just open the data, you go to prop, seasonal adjustment, moving average method, and then additive. How to know additive? You inspect the graph first, and you decide based on the graph. Okay, so you get this estimate and then select just the value given here. 89.33. Okay, so if you want to use R, you have to import the data first. Okay, just quickly do it. So import the data Q2. In the Q2 data file, import Excel, browse, Q2. Import data, and then just copy and paste this one at the same time. So attach first and then convert it to be type data. So notice that here we put 4. because it's quarterly data, not 12. We put 4 because it's quarterly data. TS, the name of the series that you want to convert to the times data. This I just put the name of the series, elect. Okay, this is the data that we import from the file. Start date. Either you put like this because it start from the first quarter. If you start from second quarter, you have to put bracket C bracket 2001, comma 2 close bracket. Okay, so that's slightly different. You want the series start from not the first quarter, but second quarter, third quarter. Okay, you have to put it not mistaken. You put something like this. See. Either you put 1 for the start from the first quarter, you put 2 second quarter. I think so. I will check it. So this one, but this one because we start from the beginning, first quarter is this. Okay, just to save time. So you plot to get to see the plot of the series, and then decompose using additive just like before, and then produce plot of that to get the plot of the decomposition. This time just copy paste everything. Okay, so this is the result of the decomposition using additive. The values are given here. The last one, the last question, produce time plot and then note the pronounced seasonality, use suitable decomposition method. So if you produce plot of the series, so we are able to see question number 3. You produce plot, insert graph. So you can see that the magnitude of signal should increase as the level of the variability is decreased. So it is more suitable to use multiplicative. In terms of calculation, I have already provided here. So just your job is just to understand it. Okay, understand at home later on. So there are 2 ways to calculate normalize. Again, I'm not sure whether you can call this normalize because it's not really equal to 1. But this is the one that we use by R, this one is what I use. So if you use Q3, you open the data, export. You go to prop, seasonal adjustment, moving average, added multiplicative. Okay, so you get this estimated seasonal index and this is the adjusted values given here. Okay. If you use R, then similarly you have to import data first. Import Excel, locate the file in the from where you save it. So Q3 okay, so we have import the data. So what we need to do next is to attach and then convert it to data quarterly, time series quarterly, and then you guys can produce plot. And you can perform decomposition using this, decompose the name of the series and then manipulative, and then produce plot of decomposition. We can do this one first. Okay, this one. So you can get the base from here. Okay. All the estimate of seasonal index, trend, random, or regular multi model. So seasonal index, seasonal 0.96051, 0.961. The first formula. Okay, so if you're not able to do it, just try to do it at home. Later on, it's not that difficult. The only thing is that the R is quite sensitive, so you need to. I mean, if small error, even nothing, small error, it will make you, will prevent you from getting the result. So you have to check carefully what you type. Okay, I think that's all for today. So see you again on Thursday for our next lecture, for the next topic on how to model trend and seasonal variation using regression algorithm. I think we have about 18 students. The new code registered. If I refer to the spectrum, but here only 16. Please do not sign for your friend next week.